Hi everyone! Today we're going to be talking about equations of lines. Our objective for today is that students will be able to write equations of a line in slope-intercept form, standard form, and point-slope form. Let's get started. Alright, so most linear equations are either written in slope-intercept form or standard form. Slope-intercept form is probably the most common form, and hopefully you're familiar with it. Slope-intercept form is y equals mx plus b. All right, where m stands for our slope and b stands for our y-intercept. And our y-intercept is where our graph crosses the y-axis. All right, if we want to write an equation of the line in slope-intercept form and we're given the graph, we need to identify two things, all right? So our goal is going to be to write it in the form y equals mx plus b. So the first thing we need to identify is what is our m and what is our b. So we can easily identify our b by looking at the y-axis, which is this vertical line. All right, that's our y-axis. This is our x-axis. So our b is, where does our graph cross the y-axis? Well, it crosses the y-axis at this point. So we go from 0, 0, all right, and we go down 1, 2, 3. So our b, or our y-intercept, is going to be -3, all right? So b is -3. Then we want to ask ourselves, what is our slope? So just like we did last lesson, we find our slope when we're given a graph by looking at our rise over run. So our rise, we're going up 4 and to the right 2. So our slope is 4 over 2, which we can simplify to 2. Okay? Now, we want to plug our m in for here and our b into here. So if we wanted to write an equation of the line in slope-intercept form, we leave our y and we leave our x alone, and we plug in our m and our b. And there's our equation of the line in slope-intercept form given the graph. All right, let's practice on one more example. So our goal is to write it in the form y equals mx plus b. We can easily identify our m and our b by looking at the graph. So first of all, our b is, where does it cross the y-axis? Well, right there at 0, 0. So y equals 0. And then our m, how do we go from one point to the next? So we went down 1, so our rise is -1, and over 3, so our run is 3. Therefore, our slope is rise over run. -1 over 3. Then we want to take our m and plug it in for m, take our b, plug it in for b. We write y equals, and we leave our x exactly how it is, plug in our m, and plug in our b, plus 0. All right, now we don't ever have to write plus 0, so we can erase that. We don't need to write plus 0. And our equation of the line is just y equals -1/3 x. All right, another common form you see is standard form. And standard form is ax plus by equals c. And there's a couple important things we need to know about a, b, and c. So first of all, a, b, and c have to all be integers, meaning, oops, I can't spell integers. They need to all be integers, which means no fractions or decimals, okay? Integers are all positive or negative whole numbers. So we can't have fractions or decimals when they're in standard form. A, B, and C cannot be a fraction or a decimal, all right? So there's our standard form. A, B, and C are all integers, no fractions or decimals. And A has to be positive, all right? A cannot be negative. A must be positive. Now, because standard form does not give you the slope of the line, there's no m in there, what we want to be able to do is convert them from standard form into slope-intercept form. So we want to go from ax plus by equals c to y equals mx plus b. So our goal is to get it in the form y equals mx plus b. So number 7, what we want to do is get y by itself. So in order to do that, we would subtract x from both sides. Our x's would cancel out over here, and we would be left with y equals 6 minus x. However, we want it to be in the form y equals mx plus b, so we want to rewrite this as y equals negative x plus 6. So our slope, or our m, is -1, and our b, or our y-intercept, is positive 6. And that is how we convert from standard form to slope-intercept form. All right, number 9. Our goal is to get it in the form y equals mx plus b. So what we should try to be doing is isolating y. We want to get y all by itself on one side of the equal sign. So first thing we want to do is subtract 2x from both sides. These will cancel out. We're left with negative 4y equals negative 2x plus 28. All right, I wrote the 2x first, the negative 2x first, because our goal is to get in the form mx plus b. Then we want to get y by itself, so divide both sides by negative 4. We're dividing everything by negative 4. All right, so when we do that, on the right side, what we're doing is we're saying negative 2x divided by 4 and negative 28 divided by 4. We're dividing everything by negative 4. So on the left, we're left with y equals negative 2 divided by negative 4. We can simplify this to positive 1/2 x. 28 divided by negative 4 gives us negative 7. Now our line is in slope-intercept form, and we're done. If we were to go to try to graph this, we would easily be able to because we can identify the slope and the y-intercept. All right, I want you guys to try number 11, convert it from standard form to slope-intercept form. Give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten y equals negative 3/4 x minus 2. So our goal is to isolate y. So the first thing we want to do is subtract 6x from both sides. Then we're left with 8y equals negative 6x minus 16. To get y by itself, divide both sides by 8. So we're dividing everything by 8. The 8's over here will cancel out. We're left with y. Negative 6 over 8 will simplify to negative 3/4 because we divide the top and the bottom by 2. Can't forget to bring down the x, and then negative 16 divided by 8 gives us negative 2. All right, if you have any questions, call me over so I can help you. Otherwise, let's move on. All right, so last time we talked about the slopes of vertical and horizontal lines. Hopefully you can remember the slope of a vertical line is always undefined, okay? And the slope of a horizontal line is always 0. So we talked about their slopes, but we did not talk about how to write an equation of the line for vertical and for horizontal lines. So something I want you to see is that when we're dealing with vertical lines, a vertical line is written in the form x equals a, where a represents the line's x-intercept. So that number, it's always going to be x equals a number, and the number is where does it cross the x-axis. That's your x-intercept. So if we wanted to write an equation of the line for this line right here, we would say where does our vertical line cross the x-axis? Would be right here, and it would cross it at x equals -1. So the equation of this line would be x equals -1. All right? And that's a horrible x. Let me rewrite that so you guys can tell what I'm writing. X equals -1. And that is the equation of the line. X equals -1 represents a vertical line at -1. All right. Now, horizontal lines. So when we're dealing with horizontal lines, we know the slope is 0, and it's always going to be written as y equals a number, and y equals a, where a represents the y-intercept. So if we're looking at this horizontal line right there, all right, what we want to ask ourselves is where does it cross the y-axis? Okay, that's our y-axis. This is our x-axis. So it crosses the y-axis at y equals 3. So therefore, the equation of this horizontal line would just be y equals 3. All right, y equals 3 represents the horizontal line at 3. All right, so now we can compare equations, and by identifying the slope, we can determine if lines are parallel, perpendicular, or neither. So this is going back to last lesson. Hopefully you can recall that if two lines are parallel, that means their slopes are equal. If two lines are perpendicular, that means we flip them and change the sign. They're negative reciprocals. And neither just means they're not equal and they're not negative reciprocals. All right? So for number 1, our goal is to get them in slope-intercept form, because if they're in slope-intercept form, we can easily identify the slope, right? Slope-intercept form is y equals mx plus b, where m is our slope. So we can identify the slope of this first line. M, or our slope, equals 5. In our second line, m is 5 as well. Our slope is 5. Therefore, they have the same slopes, and we can say that these two lines are parallel. And that's it. Problem number 3, not so nice and easy, all right? We can't just easily identify the slope because both of these equations of the line are in standard form. So what we need to do is convert them to slope-intercept form. So we want to convert both of them to slope-intercept form. We want them both to be in the form y equals mx plus b, okay? So our goal is to get y by itself. So subtract x from both sides. These will cancel out. We're left with 2y equals negative x plus 2. Divide by 2, divide by 2. These 2's will cancel out, and we're left with y equals negative 1/2 x plus 1. All right, that's the equation of that left line. Then over here on the right, we want to subtract 6x from both sides because our goal is to get y by itself, so it's in slope-intercept form. Y equals negative 3y minus 6x plus 21. Divide both sides by negative 3. So these will cancel out. We're left with y equals positive 2x minus 7. All right, now they're both in slope-intercept form, so we can easily identify that slope, the m. So the slope of this line is negative 1/2. The slope of this line is 2. All right, or think of it as 2 over 1. Therefore, these are negative reciprocals. If the slopes are negative reciprocals, then our lines are perpendicular. All right, and we're done. All right, number 7. We have one of these in slope-intercept form already. All right, this one is already in slope-intercept form, so we can easily identify that our slope of this line is 1/3. The one on the left, not so nice. All right, we have to get it in slope-intercept form. So we want to subtract 3x from both sides. Cancels out. We're left with negative y equals negative 3x plus 2. Now, we can't have a negative sign in front of that y, so what we have to do is divide both sides by negative 1, all right, because there is an invisible 1 there in front of the y, so it's negative 1y. If we divide both sides by negative 1, the negatives cancel out over here. We're left with y equals negative 3 divided by negative 1 gives us positive 3x. Positive 2 divided by negative 1 gives us minus 2. All right, so that is the equation of that first line in slope-intercept form. Now we can see that the slope of this line is 3. So m equals 3, or think of it as 3 over 1. Now 3 over 1 and 1 over 3, while they are reciprocals, they are not negative reciprocals. They are the same sign. So they're not negative reciprocals, they're not the same, so we cannot say these are parallel or perpendicular. We would say that these are neither. All right, they're neither parallel or perpendicular. All right, so I want you to try number 9 on your own. Tell me, are they parallel, perpendicular, or neither? When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten that these lines were parallel because they have the same slope. So the first one was already in slope-intercept form, so we can easily identify that the slope is negative 1/4, all right? Then over here, it was in standard form, so we had to convert it to slope-intercept form. So we subtract 2x from both sides, divide by 8, we get y equals negative 1/4 x plus 7. So therefore the slope is negative 1/4. They have the same slopes, so therefore these lines are parallel. If you have any questions, call me over. Otherwise, let's move on. All right, so number 11 and 12 are both a little unique, and that's why we're going to do both of them, all right? So number 11, we've got y equals negative 7 and x equals 2. So what I want you to remember is anytime we have y equals a number, that's always a horizontal line. And if we have a horizontal line, we know that the slope equals 0. Now, anytime we have x equals a number, that's always a vertical line. And vertical lines have a slope of undefined. Now, anytime we have a 0 slope and an undefined slope, these are negative reciprocals. Therefore, these lines would be perpendicular. All right, so this is one special case that you need to be aware of. All right, and number 12, you have x equals 9 and x equals negative 5. So if we were to imagine this on a graph, all right, we would look at our x-axis and we would say x equals 9, so we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we would draw a vertical line here. All right, that would be x equals 9. And then x equals negative 5, 1, 2, 3, 4, 5 this way, and a vertical line there. All right, so these would be our vertical lines. All right, x equals negative 5 and x equals 9. Now, both of those are vertical lines, and both of them have a slope of undefined. All right, so both have the same slope. If they have the same slope, they are parallel. All right, and as you can see by looking at this graph, both of those yellow lines will never touch. They will never intersect because they're both vertical. They are both perpendicular to the x-axis, and they are parallel to each other. All right, the last formula we're going to learn today is the point-slope formula. So the point-slope formula is used when you're given a point and when you're given the slope. Hence the name, point-slope formula. All right, so if you're given a point, x1 and y1, and you're given the slope m, we use this equation. We say y minus y1 equals m times x minus x1. All right, and you have to be sure to distribute and solve for y because we want our final answer to be in slope-intercept form. So our final answer should always be in the form y equals mx plus b. All right, but we can use this equation to get there. All right, type 1, if we're given a point and the slope, first thing we want to do is label everything, x1, y1, and m, and we want to identify our formula, so we're going to be using y minus y1 equals m times x minus x1. Then we want to plug everything in. All right, so we're going to plug 4 in for x1, 1 in for y1, and 2 in for m. So what we write down is y minus y1 is 1 equals 2 times x minus 4. All right, we plugged in all our values. Then we have to be sure to distribute and solve for y because our goal is to get our final answer in slope-intercept form as an equation of the line in the form y equals mx plus b. So we keep the left side how it is, distribute the right side, add 1 to both sides because our goal is to get y by itself. These cancel out. We're left with y equals 2x minus 7. And that is the equation of our line in slope-intercept form. All right, we had to use the point-slope formula to get there, but our final answer is always in the form y equals mx plus b. All right, I want you to try number 3 on your own. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten 2/3 x plus 4. You're using the point-slope formula. all right? Plugging in your x1, y1, and your m. Be sure to remember that minus a negative number is the same as adding. And then distribute, and y minus 0, the minus 0 just goes away, all right? So this is your final answer. If you have any questions, call me over. Otherwise, let's move on. All right, the second type is if you're given 2 points. So if we're given 2 points, we can still use the point-slope formula, but we have to find the slope first. All right, so we go back to last lesson, and we label x1, y1, x2, y2, and we're going to be using the formula y2 minus y1 over x2 minus x1. Then we plug our values in, negative 1 minus 7 over 1 minus a negative 3. So this becomes plus 3, so we get negative 8 over 4, and our slope is negative 2. All right, now we have our m, and we have our x1, y1. If you wanted to use the x2, y2 point, it'll work. It doesn't really matter which point you use. But since we already have x1 and y1 labeled as x1 and y1, let's use those points. Now we want to plug it into the formula, point-slope formula, all right, which is y minus y1 equals m times x minus x1. Then substitute everything in. So we get y minus y1 is 7 equals m, which we just found, negative 2, x minus a negative 3. Now, need a little more space here. Y minus 7 equals negative 2 times x plus 3. Y minus 7 equals, we're distributing. All right, so we get negative 2x minus 6. Add 7 to both sides. Y equals negative 2x plus 1. All right, and that's our final answer. All right, so I want you to try number 7 on your own. Remember, you first need to find the slope, so use the slope formula to find the slope. Then take your m, x1, and y1 and plug it into the point slope formula. All right, give this one a try. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten negative 5 halves x plus 4, or y equals negative 5 halves x plus 4. Final answer has to be in slope-intercept form, right? How did we get there? We first find the slope doing y2 minus y1 over x2 minus x1. We get a slope of negative 5 halves. Then we take our m, x1, and y1 and plug it into the point slope formula. We be sure to distribute, simplify, move the one to the other side, and that's how we get our final answer in slope-intercept form. If you have any questions on this, call me over. Otherwise, let's move on to our final concept, or final set of examples. All right, so number 9. Number 9 is asking us to write an equation that's parallel to the line y equals 2x plus 4 and passes through the point negative 4, negative 1. So the key word here is parallel. We want to write an equation, so this new equation needs to be parallel to this equation. Now, if it's parallel, that means it has the same slope. So what we want for our new equation is for it to have a slope of 2. So from this equation it gives us, we take that m equals 2. And then we take this point, x1 and y1, and we're going to write an equation of the line using the slope and 1 point, or the point slope formula. So we need y minus y1 equals m times x minus x1. Plug everything in. So y minus y1 is negative 1 equals m, we know has to be 2 because this new line has to have the same slope if it's going to be parallel. X minus x1 is negative 4. And we rewrite minus the negative number is plus. We distribute on the right side. All right, you need a little more space. There we go. Subtract 1 from both sides. Y equals 2x plus 7. All right, and there's our equation of the line. So we're saying that this new line that we came up with is parallel to y equals 2x plus 4 because it has the same slope, and it passes through this point, -4, -1. All right, and we're done. Now, number 11 is saying we want to write an equation of a new line that is parallel to this line right here, and it passes through this point. So that's our x1 and our y1. However, we don't know what the slope of this line is because it's in standard form. So the first thing we need to do is convert it to slope-intercept form, all right? So subtract x from both sides. We get -3y equals -x plus 9. Divide both sides by -3. We get y equals 1/3 x minus 3. All right. Now, the slope of this line is 1/3. So if we want our new line to be parallel, it has to have the same slope. So m has to be 1/3. And this is our x1 and y1. So we plug it into our formula. Y minus y1 equals m times x minus x1. Plug all of our values in. So we get y minus y1 is -1 equals m, which we found to be 1/3, x minus x1 is 3. So we simplify this side to +1, distribute on the right, subtract 1 from both sides. These will cancel out, and our new line is y equals 1/3 x minus 2. And we're done. Last but not least, number 13, we want to write a new equation of the line. All right, and we want this new line to be perpendicular to this line. Now, the slope of this line is m equals -2, and we can imagine that as -2/1. If we want our new line to be perpendicular to this line, we want our new line to have a slope that is a negative reciprocal. So our new line, we want it to have a slope of +1/2 because we switched it and changed the sign. So our new line is going to be perpendicular to this given line because the slope is going to be the negative reciprocal. And we're going to use this point as our x1 and our y1. We plug it into our formula, all right? And our formula is y minus y1 equals m times x minus x1. So plug everything in. Y minus 3 equals 1/2 x minus 4. Y minus 3 equals 1/2 x minus 2. Moving everything up a little. Add 3, add 3. These will cancel out, and we are left with y equals 1/2 x plus 1. All right, and that is an equation of the line that's perpendicular to the given line and passes through the point 4, 3. All right, so hopefully you learned a thing or two about equations of the line today. If you have any questions, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye.